Welcome everyone to this session on adding value in manufacturing. My name is Peter Byrne and I'm the Director of Public Policy at the Australian Industry Group. And we at the Australian Industry Group are very interested, of course, in manufacturing policy and value adding in manufacturing. And along with a few other participants at this meeting, we were heavily involved in the recent Prime Minister's task force on manufacturing. And one of the interesting sort of side discussions we had in that process was around the two different meanings, and two very different meanings, of adding value. One of them is sort of an accounting or economic meaning, which is sort of the relationship between what you sell your outputs for and what you pay for your inputs. And hopefully that's positive, and then you're adding value, and that's what you pay your goods and services tax on. The other is an engineering or technical perspective, which is perhaps best described as transforming or further transforming your inputs. And that's so adding value to raw materials comes in there. Now, ideally you'd have both of these working together, but not always. We're very lucky to have two very good speakers, very interesting and certainly well-qualified speakers for this session. Dr. Swee Mak is going to talk about the role of enabling technologies in future manufacturing. And Professor Bob Clark is going to talk about how Australia's natural gas reserves can provide a competitive edge in advanced manufacturing. So I will introduce Swee and then Bob, and then we'll have a free-ranging Q&A session which will end precisely at 10 to 1 in time for us to have lunch. Swee is Director of the Future Manufacturing National Research Flagship with CSIRO. He provides strategic leadership for a $70 million a year portfolio of R&D activities, so he's well worth knowing, and they address needs across a whole range of sectors. Over the last 3 years, the flagship has partnered with over 300 companies and research organisations, both in Australia and abroad. Swee is currently a board member of the Victorian Direct Manufacturing Centre, and he was elected to chair the steering committee of the South East Melbourne Innovation Precinct earlier this year. He's a member of the Monash University Civil Engineering Industry Advisory Committee and is a senior fellow in the Department of Infrastructure Engineering at the University of Melbourne. So please welcome Swee Mak.
Thank you, Peter. Good morning, and thanks for having me this morning, and thanks, Robert, for the invitation. I just remarked to Peter earlier on that there is indeed life after the Prime Minister's task force work. So I had the pleasure of actually working with Peter and Roy during that pretty hectic 9 months or so, and I did recall that conversation we had about adding value, whether or not you can create value within that segment of the value chain that you play in by just being the best at what you do, or is it always necessary to move up the value chain? And I think here in Australia, I think we're still kind of struggling through some of those issues. Today, I'd like to talk to you a little bit about the role of technology, and accepting fully what Roy has just said earlier on, that I think innovation is not always about technology. A lot of innovation actually happens at the coal face in terms of how companies manage and run themselves. But I guess it wouldn't come as any surprise that, since I come from a research organization, we do see enabling technologies having a role. And potentially there might be some game-changing technologies that we should be taking a good hard look at. And what I'll be talking to you, obviously, is just a subset of what's possible. And it's interesting that a lot of things I'll be touching on, in fact, do mirror that list that you heard earlier on from Teresa. So in terms of, I think, the way that people are thinking about the future of manufacturing and the role of enabling technologies, there are many common touch points because we are seeing various technology platforms emerging where they really require us to take a good, hard, serious look at how they can add to competitiveness of manufacturing in the future. But I think in Australia, it's very important that we work out what works for Australia. We have a very unique manufacturing sector in a sense. It's dominated by very small companies. We have a few large ones, and then there's a long tail of extremely small companies. And we live in a large country, geographically dispersed, small local markets, and so on. And it's always very tempting to look at what happens elsewhere. Just say, gotta have that, transplant it into Australia. But we need to ensure that we actually have a capacity, to be able to adopt some of those things, and that it actually makes sense in terms of adding competitiveness and transforming Australian manufacturing. So you will hear a lot of buzz, around certain emerging platforms, and you always hear that. The challenge is really working out what works, for Australia, and how you actually get broad-scale adoption. So those are some of the things that we're doing, in the National Research Flagship on Future Manufacturing. And I would like to, where do I point, actually? Okay. All right. So if you allow me, I'll just do a very quick introduction on the National Research Flagships. Now, flagships are a very important part of CSRO. By the end of our next strategy period in 2011 to 15, the flagships will constitute approximately 2/3 of the organization. Now, the flagship program started some 8-9 years ago as an attempt to bring together capability in an integrated fashion to solve large-scale national challenges or to capture large opportunities for the nation. Future manufacturing being one of the flagship, I guess, does signal the way that CSRO views the area, that manufacturing is a very important sector for Australia. And given the transitions that manufacturing has been going through over the last few decades, and particularly this recent period, where there's so much stress on the sector, we've got a flagship program, that's targeted towards certain interventions that we hope, will assist manufacturing companies, right? Oops. Okay. So the Future Manufacturing National Research Flagship, the mission is to help manufacturing companies become more competitive, productive, and sustainable through resource-efficient, cleaner, and transformative technologies. So I guess going to a question, posed by one of the members of the audience earlier on, the mission of the flagship explicitly recognizes not only the challenges that are faced by manufacturers out there, but as well as the opportunities that the emerging, I guess, greener economy provides for manufacturers. So not only do manufacturers have to become much more resource efficient in the way that they operate, but there's actually huge market opportunities that manufacturers can capture because there's a growing demand for sustainable products everywhere that you care to look. We are one of 11 national research flagships, and as Peter mentioned earlier on, our impact as a flagship is captured only through delivery of research to industry. So everything we do is about partnerships. Over the last 3 years, we've partnered with probably about 350 organizations, of which 2/3 are Australian companies and about 1/3 are overseas organizations. So this recognizes that not only do we need to create benefit locally, but the growth of Australian companies, especially in the manufacturing sector, is intrinsically tied to being competitive globally. I mean, we have a small local market, so the growth of manufacturing is tied in with global market prospects. So Australian manufacturing, very, very grateful that Roy's given you a very strong context for Australian manufacturing. So you see the familiar headline figures, contribution to jobs, contribution to exports. I mentioned that we're dominated by SMEs and so on. And one thing that sometimes people do to forget is the role that manufacturing plays in supporting the innovation capacity in this country in terms of the scientists and engineers. Probably a quarter of the scientists and engineers in this country work in manufacturing or are grown through manufacturing. Then there's all the other, flow-on effects, the multiply effects, as manufacturing transition into much more of a service-based type industry. So, there is a multiply effect as well, where, one direct job created in manufacturing probably has, one or perhaps even more jobs created in the service industries. So when you think about the pervasiveness of manufacturing in this country, it's actually a very important industry, and just go beyond those headlines you normally see, unpack that a little bit, and you see how important manufacturing actually is. But having said that, there's no shortage of challenges. I mean, there's a huge list of challenges that manufacturers face. Not the least, the pressure from the high dollar, global competition, it's been going on for 3 decades now. I think the phenomena of operating a high-cost environment, that's probably a more recent one, probably in the last 3 years or so, where Australian manufacturers suddenly find themselves in a situation where they're operating as the Scandinavians have done for decades. We are operating in a very high-cost environment. That wasn't the case when the Australian dollar was at 60 cents to US dollar. The largely SME-based ecosystem we have in manufacturing poses some challenges, particularly in innovation, because very fragmented, not a lot of absorptive capacity within firms. Then the issues of remoteness and so on. Productivity dip in the last decade. That's been a source of concern as well. And of course, looking much more broadly, having to transition into a resource-constrained future. So we had a long think about some of the drivers for change in manufacturing, and CSIRO conducted a study on megatrends. In fact, I'm embarrassed that this is actually outdated now, because our CEO just a week and a half ago, at a National Press Club, which presented a new set of megatrends, about 10 new megatrends, and these are the old ones. But I guess the substance of it remains pretty much the same. It's the changing demographics. It's about resource constraints in the world. It's just having to be much more sustainable, doing more from less, but also recognizing that there's this deep move towards personalization of products and services, and that convergence between the physical and the digital worlds. So in that sense, we actually extended the analysis to see what the implications are. If you look at those megatrends, which we believe are likely to affect the way we work, live, and play, then what are the implications of manufacturing? So this is a piece of work that we did as a contribution to the Prime Minister's Task Force. And if you look at those megatrends, you begin to see some implications. Not the least, the drive for green growth. So in response to moving towards a resource-constrained future, so what are the solutions there? I think a lot of the thinking in the future really need to be couched in terms of green growth, which is economic growth with environmental sustainability, and that needs to go hand in hand. We are looking at blurring of the boundaries between products and manufacturing and services. So not only are companies selling products, they're actually offering service solutions. You're looking at emergence of markets in the BRIC countries, so as well as in the broader kind of greener economy that actually produces a lot of new opportunities for manufacturers. So, and also in the Australian context, I guess the rise of the information economy, aided by the high-speed broadband infrastructure, whatever form that it takes, in the future, over the next 10 to 20 years, we're going just to see a pervasiveness of high-speed broadband across the economy. So what does that mean? We can only see upside for manufacturing because there's a lot of new technology, that you can leverage off, that infrastructure. So, kind of putting all of that together, if you're looking at some of the sources of competitive advantage for future manufacturing, you see a few headline items coming out. So in terms of building manufacturing towards a competitive, productive, and sustainable future, well, sustainability, that's almost a no-brainer. I mean, more and more you're beginning to see examples where sustainability in itself can be seen as a competitive advantage, for companies. But of course, we take the term sustainability slightly broader than just environment. It's just business sustainability, right? So it's not just about how you pollute and how you use resources, but it's also what makes you sustainable as a business. Maintaining license to operate, playing into the sustainable products market, becoming more resource efficient. Those are the headline items. Speed and agility will be very important. Markets change, technology cycles get compressed. The ability of companies to work out what the market needs, very quickly develop products to suit those markets and get ahead of the competition. If you speak to CEOs of biomedical products, manufacturers, for instance, they will tell you that speed is everything, right? Slow down and you die. So I think that having a speed and agility in a company to be able to very quickly adapt to changing market demands could well be a key competitive advantage in the future. So it's about responsiveness, it's about customization, it's about speed to market. Scalability. So Australia, we did a piece of work with the Future Manufacturing Innovation Council not too long ago, which did a SWOT analysis of the Australian manufacturing industry. And one of the competitive strengths of Australian manufacturing is the ability to do low volume manufacturing. Generally, we may not, there are many segments where we cannot compete, on scale and cost. So the idea here is, are there segments that it can compete on scope? Okay, the breadth of scope, the ability to do a range of things quite well and quite fast, as opposed to the ability to do very few things, a lot of it, and trying to squeeze economies of scale. And I'm sure, I'm no economist, I'm sure people will have a field day with those ideas, but I think that's something that we need to have a look at. So low volume manufacturing, reconfigurable, scope versus scale. Smart. Well, I guess that's no-brainer. I mean, you really don't want to do anything that's not smart, right? So we're talking about smarter materials, smarter processes, smarter information systems, and something that Roy alluded to earlier on about design, the role of design innovation and how design can actually lead innovation in companies. Services. More and more companies are extracting value by being not just makers of products, but by producers of solutions. You're seeing that happening on a daily basis. So, how do businesses think about their business models and the way that they work, that they operate in the market by, delivering solutions? Well, I cheated here. You see all the S's. So these are the 7 S's of manufacturing competitiveness. I just cheated a little bit. So resources. I think Australia is uniquely placed in as much as we often talk about the mining boom and potential adverse, impacts of the mining boom on manufacturing. The mining sector in itself presents opportunities for manufacturers in the med sector, for instance. So there's been a lot of, complaining about manufacturers not being able to play, into that sector. Do manufacturers truly understand the potential opportunities within the med sector? How do we link them in, perhaps through consortia, clusters, changes in procurement practices, that sort of thing. So we are beginning to see more and more manufacturers shift their focus, right? So equipment manufacturers, component manufacturers that used to do automotive had shifted to aerospace, and now they're shifting to heavy rail that supplies the resources sector. You're seeing that happen, particularly for companies that are dynamic and surviving, as opposed to companies that are sitting still. And understanding the supply chains. I like the term that Roy used about being, micro multinationals. Not necessarily needing to be very large yourself, but totally understanding your place in the world and understanding where you fit in terms of supply chains. So you hear a lot about Asian century and all the opportunities that present itself. Our feeling is that certainly our observations, a lot of companies don't quite know, the supply chain opportunities, and even if they did, don't quite know how to get there. So a lot of companies probably need a lot of help with that sort of thing. Oh, by the way, when I talk about resources, I forgot to mention, the other natural resource advantage we have is in agriculture, obviously, with food production and so on. So The flagship focuses on 3 areas where we believe we can make a difference. The first one is called sustainable materials, and that's just helping companies become more resource efficient in making transitions to a resource-constrained future. So that captures the whole idea of not only sustainable materials, but sustainable production, clean manufacturing. The other area of focus for us is factories to the future, where we need to begin to think about ways of production that are not necessarily, in the same way that in conventional factories operate currently. So how do we assist companies become much more agile, much more flexible, perhaps doing manufacturing in a distributed fashion? So I'll touch on that a little bit afterwards. And the third one is just transformative industries. These are activities that we do that help catalyze the growth of new supply chains in areas that make sense, in areas that we have a comparative advantage to do so. So generally through disruptive platform technologies. And of course, in the Australian context, doing all of that whilst thinking about how we can most effectively maximize our comparative advantages, not only in the resources that we have, but in terms of the capabilities that we have, whether or not they're technological capabilities, R&D, or business knowledge. And of course, leveraging the infrastructure. You probably got a sense from Roy's talk that we have a fairly big innovation system that really is probably not very well connected, not well leveraged, not well coordinated, and not well integrated. So how do we make the best use of all that investment in infrastructure that we've got? And we're doing all of this recognizing that manufacturing is changing. Right? More and more, we don't see manufacturing as just making stuff. We see manufacturing as that whole broad range of activities that starts from design to the end of life, treatment of products, and including the services that goes with supporting a product during its service life. So previously, we normally looked at the front end of the value chain. How do we make things? I think more and more, it's how do we manage the entire product or service offering through its entire service life. And that's how roughly our focus areas map on to the whole manufacturing value chain. With design, we see design being intrinsic to the entire value chain, through the whole life of a manufactured product service offering. So, well, we certainly believe that competitive advantage comes from innovation, whether or not you're trying to transform an existing company for what we call sustainable competitiveness, or in effect enabling future companies to be formed through disruptive platform technologies. But recognizing, as I said earlier on, that technology is one part of the solution. It's not all, technology doesn't solve all problems. A lot of other things have to happen as well. So I'd like to just step through some areas where we believe there's a lot of value to be added to manufacturing. Some of these are things that we currently already do, and there are many successful case studies of them. Some areas are emerging. It's something that we're taking a good hard look at, not only ourselves, but with others as well, across the national innovation system. Sustainable high-performance materials. There is a need and there's an opportunity. So there's a need in terms of just helping companies produce products that are much more sustainable, but in itself, there's also a market for sustainable products. So we're beginning to see many manufacturing firms invest in technology and innovation in that area. Talking about smarter multifunctional materials with superior whole-of-life performance, and materials that are easier to make, so that you actually become a much more efficient manufacturer. So I'll just give you 4 quick examples. New cable technology that at some advanced nanomaterials that's gone into actually making it a much cleaner production process, but with very special properties in terms of its fire resistance that allows a company called Olex and Nexans to capture opportunities in a $12 billion global market. timber pallets. Now, you would not have thought about this as something truly innovative. And Roy actually reminded us that a lot of manufacturing is actually low to medium tech. And here's an example. Now, timber pallets, global timber pallets for export consumes about 30% of the world's hardwood forest. It's a $90 billion market. So here's a technology that is renewable, recyclable, that a company in Australia has begun to take to a global market with plans to actually build a production facility here in the Hunter Valley, and with a global franchise. Once they start getting going, again, it's a material solution that actually produces a huge resource and environmental impact. Top coat. No, this is zero waste powder coating. It's a method of painting plastics, which is free of volatiles, 100% recyclable. And when you think about the gigaliters of paint that's used in the automotive industry a year, this technology was developed with Dulux. It's currently being commercialized, and in Australia, we expect that when fully used, will save the automotive painting industry about $200 million a year alone. So multiply that with the global market. Top coat reactivation. Now, this is a method of a clean painting, which actually allows aircraft companies to paint without having to scrub the plane first, because quite often you have to sand the plane before you actually put on the next coat. This is a paint on and spray on technology that reduces hanger time and so on. That's really on 1,000 Boeing aircraft at the moment, and it will be put on every single Boeing 787 Dreamliner that rolls off the production line. So again, an example of clean, highly efficient, safe manufacturing. So the next area I want to touch on is building speed and agility, so towards factories of the future. There are many elements to this, and we had a discussion last week where there was a heated debate whether or not it should be agile or flexible or reconfigurable. So I guess we are all kind of still working through the semantics and the terminology, but really the intention here, is to actually provide companies with a much wider range of possibilities to operate in a more agile way. So faster discovery. When you look at traditional chemical production, and when we say that speed is everything, in the past you will actually discover chemicals one at a time. Now we use high throughput technologies where you can actually do 500 reactions at a time. So can you imagine how that actually accelerates the process of discovery? Scalable, intelligent processing. When you're making chemicals in the past, you tend to cook them up in batch reactors. Now we do it in tubes, so that you can actually have reactions that occur in small streams of liquid. You no longer need to have large batch reactors. So the impact of that is not only to speed up production, but you can actually scale. You don't have to make a fixed quantity every time. You can actually make as small a batch as you like or larger batch as you like. If you need a larger batch, you just put many more tubes in. And you can actually react a lot of these chemicals at lower temperatures. And we have examples where it used to take 16 hours to make a reaction happen. Some of the processes we're using takes minutes. So that has to matter to some of the chemical manufacturers. And an example of a scalability again, a mixer, an inline mixer that mixes twice as well, but reduces the energy of mixing by about 5 times. So this has really been implemented in the food production industry. Additive manufacturing, you hear about all the time, 3D printing. There are a lot of toys out there, so that it's fun. It's a bit of a hobby. It's been used a lot for rapid prototyping. The challenge is to take it into manufacturing. So the real challenge is to move beyond just rapid prototyping. Make it serious and take it into manufacturing and see whether or not it's robust, it's scalable, and whether or not it's cost effective. So, but the opportunities are immense because of the flexibility, inherent flexibility of additive manufacturing techniques. So additive manufacturing, it's about making things in layers. So build them up layer at a time. It can be either metals or it can be polymers, and they can be ceramics as well. So there's a lot of technology out there. Question is to find the right ones that will make sense for certain types of manufacturing applications. So I'll give you an example. If you want to make a part, the one on the right-hand side, what you do is take a block of metal and machine it. With additive manufacturing, you can actually make the same part with either powder or wire, with the result that you actually reduce the amount of waste by huge, huge margin. So in the aerospace industry, they use this term fly-by ratio. Basically, if you buy 1 unit of material, how much of it actually gets to fly. And the ratio is about 10 or 11 to 1 normally when you're machining a block of metal. You can get down to 1 to 1, roughly 1 to 1 for additive manufacturing. So in effect, you've actually saved about 10 times of materials. Well, that's just a picture of some pretty fancy electron beam melting equipment when you look at the sort of products that can actually be made. What you can do is free-form manufacturing. No longer do you need molds. You don't need to cast materials. All you need is a data file. And whatever the designer has conceived, or it could be a scanned image, the machine will actually make it for you. The challenge is materials, whether or not they will actually be fit for purpose, and whether or not you can actually make things cost-effectively enough. New materials, leveraging our comparative advantages. We saw flexible electronics on that list with the Obama report. Australia is pretty good at polymer science. Polymer banknote technology, well, that was developed at CSIRO. We're actually leveraging on that technology now to make printed flexible electronics with applications in LEDs, organic photovoltaics, and so on. The global market for flexible electronics is very large as well, very competitive, very large. And there's also an opportunity, if we do this right, that we can actually transform the printing industry in Australia. So people who used to just print normal magazines and publications can now be printing solar cells and sensors and LEDs. Just a couple more slides. The other area that I thought I'd just mention briefly is titanium. Not necessarily advanced material in itself, but we have 40% of the world's reserves in titanium. So are we determined to add some value to it and actually make something of our reserves, or are we going to go down the route of a lot of other minerals where everyone else is actually adding value on our behalf? We have a fairly significant program that works on taking titanium ore and making powder and wire in a very cost-effective way, and then taking all the way down to the manufacturing end through additive manufacturing. And it's a no-brainer. The ore is worth less than $1 a kilo. An added value titanium product is at least 100 times that, if not more. So there's a massive manufacturing opportunity, and a lot of the applications are in the high-end, aerospace, biomedical, sectors. So for us, it's a strategic comparative advantage that we have in this country. We are at no disadvantage to capture the opportunity, right? And that's something that we're working on. And I'll finish off, with just a quick discussion on lightweight and assistive robotics, which Roy mentioned earlier on. One of the ways in which we potentially could lift productivity in the workplace, and particularly with an aging population, as well as with perhaps a loss of skills in some segments as people move to other sectors, is through lightweight and assistive robotics. This is about changing the paradigm for Australian manufacturing. Industrial robotics, generally expensive, beyond the reach of a lot of SMEs, and also large-scale heavy industrial robots have that problem that you can't actually get people to work close to them. What we're talking about is changing that paradigm, and see my colleague at UTS nodding there, because we've been working with you guys to think about these issues, is how a whole new generation of lightweight robotics can actually make for a much more productive and friendlier workplace where human beings can interface with robots a bit more readily. And you're looking at a whole range of technologies that allow humans and machine to interact, tracking of activity on the work floor and using augmented reality type technology with remote tele-guidance so that even unskilled workers can be guided to do highly complex tasks. mapping technologies that can actually map, in 3D in real time what's happening around a production floor, so that you can keep much better track of, activity and optimize movement, inventory, and so on. And here's an example of a, lightweight robot assistant that actually interfaces with all parts of that, production setup. It connects a supervisor to the worker using augmented reality, instruments that allow them to actually do complex tasks. And finally, we should not forget design. There's a lot of discussion about the role of design, and I think in this country we're just at the beginning of taking design seriously. There's a community being built, to look at how we can bring that capability together to really make design, useful and a source of competitive advantage for manufacturing firms. And there's a lot of data out there that kind of plots, competitiveness versus the degree of, design in companies. And generally, there is a correlation that where companies use design as a source of competitive advantage, the competitiveness goes up. There are even charts about, stock market performance of companies that are more design-based. And perhaps just one last thing. I've talked about a whole range of enabling technologies here, but technology is really not enough. And Roy showed that, Terry Cutler's report, Venturous Australia, where he's really making the point that unless you have the ability to translate and transfer and make sure that companies make use of it effectively, technology is just a means to an end. If you're not getting it out there and making it useful, nothing really matters. And one of the things that we are talking about, CSIRO started a process of mapping out a precinct strategy over the next 4 years. We would like to progress that. It's something that we kind of put it out there for discussion. This is the whole idea of building, large-scale interconnected ecosystems where all parts of the innovation system can interact more effectively, right? And with regard to manufacturing, well, there are 5 that are on the table at the moment where we're having discussions on. So these are all fairly early-stage concepts. There's a proposal for an Australian manufacturing materials innovation precinct at Clayton, which actually focuses on advanced materials and clean manufacturing technologies. But we don't see these precincts as happening in isolation because they're all part of an interconnected system. So basically, it's just hubs in virtual networks. And so hopefully, we'll be seeing much more discussion of that, with all stakeholders and taking those ideas further. And while on that, we also have a couple of proposals on building national research networks. One's on design integration and one on additive manufacturing. Thank you for your indulgence. Thank you. Thank you for listening.
So we're going to have an opportunity to ask questions in a moment. But first of all, I want to, invite Bob Clark up to the lectern, and I'll just provide some brief introductory comments. Bob was appointed Professor and Chair of Energy Strategy and Policy at the University of New South Wales a couple of months ago. And he has a focus in this role on evaluating the potential for unconventional gas to play a role in Australia's reduced carbon footprint energy mix, as well as developing responsible strategies and policies with regard to environmental impact. Bob was formerly the Chief Defence Scientist of Australia and Chief Executive of the Defence Science and Technology Organisation. He comes with having been awarded the Australian Government's Federation Fellowship twice, and is a Fellow of the Australian Academy of Science, and he's also been awarded the Australian Defence Medal and the Australian Centenary Medal. Still, he's got time for us today, and thanks very much.
Thank you very much, and first of all, I'd like to thank Robert Hill for inviting me to participate in this very nice event. I'd like to preface my remarks by just saying a few words about the alliance between Australia and the United States. This is very close to my heart. Not only, in my opinion, has this built a strong bond between our two countries, but it's also built very strong bonds between individuals who serve our countries. It's actually very personal, it's withstood the test of time, and it's withstood the test of circumstance. Long may this be so. And having said that, I'd also like to mention that I formed a collaboration in this work on energy with my former defence colleague Peter Jennings, who was a Deputy Secretary of Strategy. And Peter and I served on Australia's Defence Committee together for 3 years and had to think about many strategic situations. And I've recently been appointed to be a member of the Australian College of Learned Academies expert working group that's looking into shale gas in particular in Australia. That working group is in the midst of collecting evidence and preparing its report to the Australian government. And with that in mind, I won't be saying very much at all about shale gas until that report comes out, but I will be touching on shale gas just in this talk from the point of where to from shale gas. I'd like to talk about 3 things as shown in the outline to my talk here. I refer to this as the energy trilogy: manufacturing, transport and electricity. And what I want to do is to connect natural gas with future fuels and then develop an advanced manufacturing scenario and look beyond research and development and scale up. I want to touch on electricity because without cheap, affordable electricity, manufacturing is not going to be in very good shape, and I've got a few words to say about that. I won't use the word green growth in my talk. I prefer to use the word khaki from my military background, and I hope to be able to give you a khaki perspective on all of this. And I'll conclude with some policy comments. Okay, see if this works. Yep. I want to start very broadly by just thinking about Australia's resources generally. And the black dots and the brown dots are coal, the yellow dots are uranium, and the red dots are gas in this diagram. Australia has 38% of the world's uranium, 9% of the world's coal, 2% of the world's gas. In terms of export, we are the largest exporter of coal in the world. We're one of the largest exporters of uranium, and we rank 6th for our LNG exports. Overall, in our energy consumption, coal accounts for 40%, oil 34%, gas 22%, and the renewables is 5%, mainly in the bioenergy area. And if you think about wind and solar in that overall energy consumption, 0.3%, just to bring things in perspective. In terms of our electricity production, 3/4 of it comes from coal, 16% from gas, 7% from renewables, but bear in mind that 4.5% of that 7% is hydro for Tasmania and the Snowy Electric Scheme, and wind accounts for 1.5% of that 7%. In contrast to our resources in coal and gas, we only have a very small fraction of the world's oil, 0.3%. And we have an increasing reliance on imports to meet the demand for our transport fuels. And that's what I really want to address in this presentation. Now, that was the conventional gas, which was largely offshore off the Northwest Shelf. We've all heard about the shale gas revolution in the United States. It's been absolutely stunning, and that's what brought me into this position in the first place, is reading about this and reflecting on the Australian situation. This is a graph produced by the US Energy Information Administration showing the shale gas estimates in the world. It doesn't account for everything in the world. The footnote at the bottom shows that Russia, Central Asia, Middle East, Southeast Asia and Central Africa are not addressed in this study, so it's only for those other countries, 48 shale formations in 32 countries. And a couple of amazing things here on this plot. If you combine Canada and the United States, that's roughly about the same scale as what has been estimated as technically recoverable from China. It's a very interesting reflection. Of course, the United States is well into this because they have developed the innovative technology to do this. China is at the very early stages. Australia has a technically recoverable resource of 396 trillion cubic feet. Now, you need to compare that with our conventional gas resource, both economic and uneconomic, that I showed you previously of 164 trillion cubic feet. This is twice as much as our conventional gas, or more. And compare it with our coal seam gas, about which you have read so much, which is only 42 trillion cubic feet. So coal seam gas is just the tip of an iceberg. Now, a question you might ask here strategically is, what happens if all of these countries act on their resource and develop this resource at some level of success over some timescale? How will that affect exports, LNG exports? How will it affect the gas price? Are we heading to a world gas price and a lower world gas price as opposed to a regional gas price? This could fundamentally change the economics of Australia. Now, with that, I come now on to transport fuel, and I want to connect these two things. This is a CSIRO study of how our transport fuels will project out to 2050. Now, if you look at the left-hand side and you see the dark blue and the reasonably khaki-coloured plot, or so it's coming out lime green on the screen, you can see that at the moment we have largely conventional diesel and petrol, namely from petroleum-based sources. But by 2022, in 10 years' time, the projection within the modelling assumptions, which I'll come to, shows a dramatic shift to synthetic fuels. Now, the modelling assumptions are very much within the carbon-constrained economy and government policy, and you can read the assumptions there, but basically this modelling fits the assumption of 60% below 2000 by levels by 2050, and it's our emission target scenario. Now, of course, that's 80% now, but this is the modelling that was done in 2008. So the interesting thing here is there is a prediction that, first of all, our cars are not going to be all electric. They are going to be powered by liquids, and those liquids are going to be significantly synthetic liquids. In particular, if you look at the gas-to-liquid diesel biting into the diesel market, and the ethanol blends, synthetic ethanol, biting into the petrol market. And petrol is almost, as a 100% resource, is taken out, as it were. Aviation fuel is increasing, but you can make jet fuel synthetically. And I now want to move on to a manufacturing scenario that brings together what I've just shown you as our gas resource, both conventional and unconventional, and our transport fuel projection, given the fact that at the moment we substantially import the bulk of our transport fuels. So the scenario I want to present to you is a gas-to-liquid scenario. Much has been said about this in the past, but I'd like to bring this front and centre. This is a very busy slide. I apologise for that. But essentially, if you look at the reactor 1, reactor 2 in the middle of the left-hand side, going from a natural gas input to a liquid output involves 2 reactors. The first reactor takes the gas, CH4, methane. It mixes it with steam, carbon dioxide and oxygen. And in that first reactor, you make essentially a thing called syngas, which is carbon monoxide and hydrogen. That syngas is then fed into a second reactor under temperature and pressure. And this is where the proprietary information of how you exactly do that is very complicated, and industries guard that quite closely. And what comes out of that second reactor is essentially medium to long hydrocarbon chains. And for the chemists among you, I've put the formula up there in the light blue band. But essentially, the 2 main transport products that come out of this is synthetic diesel and jet fuel, or kerosene, or kero as it's known colloquially in Australia. Now, does this process work? Is it manufacturable? Can it be done at scale? In my last job, I had to evaluate a lot of technologies, and I had to assess the risk for the Australian government of those technology. Invariably, the risk always lay in scale-up, in going from something that works in your laboratory, something that works in a pilot plant, even then you've got risk, to manufacturing scale. That's where the risk is. And we've heard a little from Sui about titanium, but I would encourage people to go and look at the magnesium story in Australia and what went spectacularly wrong with magnesium in going from the lab to pilot scale and then attempting to go to full-scale manufacturing with considerable public money. Shown here are two different scale plants in the world. On the right-hand side, the world's largest gas-to-liquid facility in Qatar, Shell's Pearl facility. At full scale, it feeds into it 16 billion cubic feet of gas per day, taken from Qatar's North Field. And what comes out of it is 260,000 barrels of liquid per day of product. And quite a lot of that will be transport fuel. The other shown there in the medium scale is Chevron's facility in Nigeria, and that's what a medium scale facility would show. And instead of being at the hundreds of thousands of barrels per day, there you're at the tens of thousands of barrels per day. That's the picture that I have in my mind for Australia. Now, but where are we right now? So coming on to CSIRO and the CO2 CRC, having had a look through Australian capability, this facility, SynCat, exists in Western Australia. It's a CSIRO facility and it does synthetic fuels research. It can run by itself for months at a time. It's fully automated and it's examining the barriers for the development of gas-to-liquid transport fuels. It's a public-private partnership, but you can see from the scale of this, it produces about a fifth of a barrel per day, not 240,000 barrels per day. And the investment isn't $19 billion of steel and concrete, which it was in Qatar, it's $5 million. This is a scale where we're at now in Australia. Now, if you were to do gas to liquids, which is an energy-intensive pursuit, it's also not green. So how do you make it, maybe not green, but khaki? And the answer is carbon capture and storage. And there is some work going on with carbon capture and storage in the CO2 CRC, and in particular at the Mulgrave Capture Progress, where a syngas stream is directed onto 3 CO2 capture rigs. They're looking at different efficient ways of capturing the CO2 at that facility. So there is activity in Australia both in gas-to-liquid production and in how to take care of its byproduct, namely CO2. And it's really CCUS because the CO2 is used actually in the process which I showed you previously. Now, coming back to shale gas, and this is all I really want to say about this, because it can apply to other things. Shale gas largely occurs in the middle of nowhere in Australia, as opposed to coal seam gas, which occurs in the middle of somewhere, which is our farmland. And you've all read the press about the arm wrestle that's going on between the farmers and the miners in this area. They're fundamentally technically different. And shale gas in Australia will be fundamentally technically different than the United States. And the biggest problem will be transport, because we're in the middle of nowhere. How do you transport the product to market? Pipelines cost $1 million per kilometre, and there are many kilometres from what you might regard as LNG export. So here we have a situation where we may be disconnected from LNG export markets, and that may be a problem. But conversely, it might be an asset, because if we have stranded gas which has no other useful purpose, then businesses may look at this with a different business model, namely add value to this gas because the gas is cheap. So you can do energy-intensive manufacturing, namely gas to liquid, because this is a cheap source. It's got no other value. You're not going to export it and link it to the oil price, which will be higher than the production cost. Okay, so in assessing this in Australia, we will need to look at the economics of it in a very hard-nosed fashion. Now, if you want, what the calculation will boil down to is the competitiveness of gas to liquid transport fuels with oil-derived transport fuels down to whatever value you think the oil price is going to be. Now, at the moment, the oil price is very high, but a couple of bookends here that you can get from the literature. For a large-scale Qatar-type facility, they believe they'll be competitive even if oil goes down to $20 a barrel. But if you're a small-scale biomass to liquid and you want to do CCS as well and be quite green, you will only be competitive down to $240 per barrel. In other words, you won't be competitive. So what we need to do for the unique Australian situation of this massive resource with this opportunity is to look at all the inputs to the calculation, gas to liquids versus LNG versus electricity generation or gas for electricity generation. What is the gas price? What are the oil prices? What are their projections? What are the difficulties in the middle of nowhere? What are the transport costs? What scale do we want to do it at? What precise process will we use? Can we use the water that this produces, this gas to liquid produces, to do other mining, for example? Water is required in the drilling itself for gas. What is its life cycle, greenhouse gas emissions? What emission controls do we want? And how automated do we want it to be? Do we need a FIFO, labour force? And what are the markets? So I've just shown that I believe that there is an expanding domestic market in Australia. That's a wonderful thing, which we often don't have, in our transport fuels, which will reduce our exposure to imports. That's a very good thing. Okay, now in the second part of my talk, I'm just going to finish off on electricity, because we need, for good manufacturing, not only affordable electricity, we need reliable electricity. And so here I've shown a plot, which is an Australian Treasury plot, but I've also taken this from a Grattan Institute report of Tony Woods, where he talks in different terms about this plot, so let me talk about it on my own terms here. The vertical axis is our emissions in tonnes of CO2 that the power station spews out for every megawatt hour that it generates. And on the horizontal axis is the time out to 2050. And you can see that if we are to meet the Australian government emission scenario of basically 450 to 550 part per million of CO2 by 2050, that essentially what that boils down to is we need to get below 0.2 tonnes of CO2 for every megawatt hour. Now, I think of this plot in a very simple way, and this is how I think of it. Basically, if you look at the emission of a coal power fire station, it varies between 0.8 and 1.2, but if you will, it's at the top end of that scale. If you look at the emission of a gas-fired power station, it's about half that. It's around about 0.4 tonnes of CO2 per megawatt hour. And if you look where renewables are, they're right down the bottom end, as you would expect, nearly getting down to zero emission type technology, certainly below the 0.2 level we need to go to. Now, what you can see from this plot is we could make a hell of a difference if we just went from coal to gas power stations. If we had a magic wand and we could wave that overnight, we would halve our emissions from our electricity stations. We could also make a significant contribution if we combine carbon capture and storage with either the coal-fired power station or the gas-fired power station. So let's look at where the Treasury modelling then takes you for sources of where they see this going. So blue is now and red there is 2050. Basically closing down black coal, but not quite. Completely closing down brown coal. Gas is going to see some increasing use, but the modelling shows that if we're going to get to those levels, we need to do CCS with both coal and gas-fired power stations, and renewables have to have amazing penetration into our electricity market. Now, quite frankly, when I look at that graph, I get extremely concerned. And I think that a likely scenario here, well, I ask questions like, I always ask the question, what if we fail? Now, so if I take renewables and say, what if renewables don't do that by 2050? Where does that leave us? What if we don't have carbon capture and storage? Where will that leave us? So state of the play at the moment is that we've got some small-scale carbon capture going on at power stations at the level of 1,000 tonnes of CO2 per annum. We've got a reasonably good storage project, 65,000 tonnes of CO2 stored since 2008 and monitored, one of the world's best practice in the Otway project. We've looked at sources and sinks for power stations. Shown here, the sources are blue, the red bubbles are the sinks. The numbers there are the millions of tonnes per annum that we can store in those facilities. And encouragingly for all of us, in the United States, just a few days ago, there was a press release of the world's first demonstration of the full capture and storage to 90% of the CO2 emitted by a full-scale power station in Alabama using very heavy industry capture built by the Mitsubishi Heavy Industry Company in a partnership between Japan and the United States with US DOE backing. And they are storing 500 tonnes per day in that facility in the Citronelle Dome geological structure. We all know what the Australian policy settings are. I won't go over these here. There's a lot going on in Australia, and there's a lot of money being put into the Australian situation. And this is all available through the government. Excuse me. Go back one. I just want to read one quote and then I'll conclude. And this is coming back to the alliance situation and what is the US doing in this area. And I've got here the assessment of MIT about the future of natural gas, namely that there is an abundance of gas in the world and I'll just read out this. It will be a significant error of policy to crowd out the development of other currently more costly technologies, namely renewables, because of a new assessment of the natural gas supply, namely this awash with shale gas. Conversely, it will also be a mistake to encourage, via policy and long-term subsidy, more costly technologies to crowd out natural gas in the short to medium term. So I guess my whole thesis here is concentrate on the middle as opposed to the end, because the end is risky, and if we falter in reaching that end goal, we have to have a very good strategy and policy settings for the middle. So my conclusion about this, I have two things that I am thinking about seriously at the moment. I haven't fully decided where I exactly sit. The first one is to look at stranded gas to liquid transport fuels with carbon capture, utilisation and storage in scaling up to a medium-scale plant of the order of 1,000 barrels per day. Can that be done in Australia? Should it be done in Australia? Is it economic in Australia? And finally, let's scale up from these little pilot plants we've got going on in capture and storage, and let's address one full-on, full-scale power station and do that right. Can it be done in Australia? Can we be the second country in the world to actually do that? Possibly bilaterally with the United States or trilaterally with Japan. There's some thoughts. All of this will involve engagement with industry. Thank you.
Now, I think we're all mic'd up and ready to go. We've got about 15 minutes or so of questions and Q&A. So first of all, thanks very much for two very interesting presentations. Does anyone want to kick off the discussion? I think there's a roving mic somewhere. We've got a question up the front here. A couple of mics.
Okay. This is just a question for Professor Clark, just in terms of the price that you mentioned that would make it economic for the oil price to be for the smaller biomass conversion, gas to liquid with the carbon capture and storage. Just out of interest, I was wondering how much of the $240 per barrel is due to the cost of the carbon capture and storage part of it?
Yeah, that's a very good question. I haven't gone into the breakdown of that cost. I think quite a lot of that will be in production, actually. Yeah, the biomass. The carbon capture and storage will be expensive, but if you look at the carbon capture and storage split for, let's say, just conventional power stations, 80% is in the capture and 20% is in the storage. That's the rough split in the capture and storage part of it. How that's split between the $240, I suspect it's the cost of the biomass.
We've got another question up the front.
Hi, Linda Condon. I just really wanted to ask both of you, I think it was Teresa this morning that talked about the Valley of Death, and that is between that sort of, university intellectual sort of development of research and then commercialisation. And I think particularly you three mentioned the necessity when you work with industry for speed and agility. And my own personal experience in this was in fact related to wooden pellets that I was trying to get our researchers at Swinburne University to look at to see whether they could develop something that was much more sustainable. And we got nowhere because the researchers really didn't know how to engage with industry. Yep. If you could think of two really important ways to overcome that, I'd love to hear them.
Okay, I'll have a go. Where do we start? We got all day. It's a fundamental problem, within the national innovation system here. Some people go so far as to say that the system doesn't exist because it's also fragmented, right? Through the Prime Minister's Task Force process, I think that issue has really come to the fore, that lack of connectivity between industry and research. So I think the AIG work that was done showed that companies only access about 5% of their innovation needs from the publicly funded research organizations. Unpack that a little bit, it suggests that either industry doesn't know what the researchers do, it's either the researchers don't know what industry needs, or some may know and don't care. Because I think, particularly in the university system, the incentives, the structural incentives are more towards, as Roy said, more towards, publications and so on. So whether or not there's a real incentive for them to think about industry needs and to then tailor their research. So there are all those issues as well. There's no easy answer here. That's compounded by the fact that, for instance, the venture capital market in Australia is very, very small. It's very hard to get access for early stage, funding and incubation of ideas. There's another issue that I saw one of the talks mapping out TRL. It was actually in Teresa's talk where they actually use a scale, a technology readiness level scale, which is something that we implemented in the flagship as well. There is an inherent communication problem between research and industry because we're sometimes talking about different things. So quite often, something that the researchers think is quite ready to go to market, in fact, is way off market, is nowhere near, and Bob just talked about that scale-up issue. And there is an inherent mismatch of expectations sometimes between industry and research as well about how ready something is. And so there are two scales there. One is technology readiness level, and the other one is the manufacturing readiness level. Just because you think that your TRL is fairly high doesn't mean that it can jump from 6 to 7 because maybe there's an absolute big scale-up issue that you can't get past. Yeah. It's a really, really big issue. So a lot of it is about connecting in the right way. So one of the things that's out there at the moment is a scheme called Researcher in Business, a scheme run through Enterprise Connect, which is quite a small scheme compared to equivalent schemes overseas, right? And this is a scheme where there's federal government support to co-fund the cost of a researcher that is placed inside the company. And the researcher can be from CSRO, universities, wherever. And it is a way of embedding researchers into into a commercial environment, ensuring that they actually understand how real companies work. And by the same token, having companies, I guess, giving them a resource, a research resource for them to use, in the daily operation of a company. Now, we're very supportive of that sort of program because it solves that, what we call that mobility issue. Australia, compared to a lot of other more innovative countries, we inherently have a workforce mobility issue. Researchers don't move back and forth from industry back into research. Conversely, we don't get a lot of movement from business into research. In Finland, Sweden, Denmark, Germany, you'll find that there's a lot of academics who actually move back and forth from industry. In fact, a lot of the academic work is guided by industry needs. Whereas in Australia, we just lack that mobility. So anything we can do, like the researcher in business scheme, not sure how much it will grow in the future, but that's certainly a good first step. So it's kind of a whole range of rambling thoughts to what is a very important question.
It is an important question, and it's something that people have been a nut we've been trying to crack for 2 or 3 decades, I think, here, and haven't really made much headway. It's another question. Sorry, one ahead of myself, yeah.
Hi, Susan Pun from the US Study Centre. You mentioned that the shale gas from the Cooper Basin, this is a question for Professor Clark, will be cheap. Can you tell us a little bit about the global markets for gas and why you think that we'll be able to keep our cheap gas detached?
Yeah, I guess what I meant by it being cheap, gas, as you know, gas is a regional price. It's not a commodity in its own right, although we may be heading to a single world gas price, and we may be heading to a lower gas price overall. That modelling needs to be done, hasn't been completed yet. What I meant by it being cheap is that, and this applies to all gas, not just shale gas, if your gas is stranded and it can't be used for the export market, which is, we like to export our gas at the moment because it's linked to the oil price. And as you know, there's a lot in the newspaper about Japan challenging that linkage, Europe challenging that with Russia. Meanwhile, the price in the United States is significantly lower for shale gas. It's so low that the companies aren't making money and they're going for the oil at the moment until the gas price floats up a little bit, and then they'll go back and have a go at the gas. And I've got no doubt that that will become economic. I think it's a marvellous thing that's going on. But if we have stranded gas in an Australian context, the cost to get at that gas to use it is really just the production cost. It has a value. You've got to get it out, and it costs you money to get it out. But if you then use that yourself to do the manufacturing, that's a very cheap supply of gas. You're not buying it from anybody. And so, in a very bizarre, ironic way, the fact that a lot of our gas may be isolated from the LNG export business might actually be a very good thing for Australian manufacturing, because it actually might force us to do it.
Just on that, if you would be making transport fuel, for example, out of the gas, you could export the transport fuel, presumably.
Well, look, I've just looked at the domestic market, but it all gets down to the economics. Yes, you could imagine that you could compete, but in fact, one of the things we're about to do is to get some real card-carrying economists to start do this calculation, because at the moment this is if you like, this is a strategic suggestion. It needs to be verified by hard economic numbers, but I have just a bit of a gut feel that we are in the right zone here to be competitive.
I know Roy's a card-carrying economist. Has anyone got any other questions? There's a question up here. Sorry.
This is a question for SWEMAC, Michael Smith from ANU and the United States Study Centre. Swee, I was wondering if you could elaborate a bit on the potential to achieve a step change in energy and energy efficiency from some of the technologies you discuss. You mentioned additive manufacturing gives you a sort of factor 10 reduction in material intensity, but what sort of energy intensity gains do you get? And I'm wondering, to what extent has the CSIRO flagship looked at the potential to achieve a step change in energy productivity in the manufacturing sector from cogeneration and other means? Because it seems to me that's going to be pretty critical to help us understand what sort of energy demand the gas that Robert Clark's been talking about will be needed in the future.
First of all, thanks for the question. Manufacturing is very diverse, right? So there are so many different segments and there are so many different processes. So you have, in fact, you have a very large proportion of manufacturers where the cost of energy is not really a major issue for them. I mean, they will, you know, with the introduction of carbon pricing and all that, there will be a small percentage increase in energy pricing, electricity prices and all that. But there are a lot of manufacturing business that are not energy intensive. Then there are those that are extremely energy intensive. So I can't give you a view as to broad scale efficiency gain by doing X. We can be fairly specific in terms of specific applications. Yeah. So let's say if you look at food manufacturing, that example that we've given, I've showed you on inline mixing, for instance, you can actually calculate, like a 5-time energy reduction. Then, of course, multiply that by volume of production, multiply that by, the pervasiveness of that industry in an economy, you get an idea. We are not working on the very energy-intensive metal production, industries like, aluminum and others, which is, well known, being an energy-intensive industry. So the flagship doesn't actually tackle that. With the titanium industry, which is fledgling and noting Bob's comments about magnesium, we've got industry partners, who are working with us on that. We can identify significant, savings in production costs. But then it's a small volume issue in the sense that the titanium industry is going to be a boutique, niche industry. So it will affect the energy bottom line for that supply chain. But more broadly, I think you need to look at energy from the point of view that it's not only about the direct process energy, but it's also about the embodied energy of materials. So if on a broad scale you get a reduction of material use by X%, multiplied by the pervasiveness of that material use, you do get embodied energy savings, which is embodied carbon, depending on how it was processed in the first place. I guess that actually is missing from the general conversation about energy efficiency in manufacturing. We tend to look at how much energy input is required to run a plant, for instance, or to keep a business going. But the embodied energy part is not yet part of the mainstream discussion. Right? So I'm not sure whether that actually answers your question, but the short answer is that no, we don't have programs that look at broad-scale impacts on energy efficiency, but we do have fairly targeted efforts for specific segments and specific applications, and we can quantify those, subject to the scaling up, right? Because taking it from here to here, there's a big step here in terms of the potential energy savings, because you could be incurring other forms of wastage or inefficiencies in the scaling up process that actually swamps your intrinsic energy efficiency in the first place. Yeah. So case by case.
I think we've got room for certainly one and maybe two more questions. So I think.
Okay, question for Professor Clark. You alluded pretty diplomatically to the questionable financial prospects for the major coal seam gas projects that are being rolled out in Australia's best farmland at the moment, given the increased global supply and the likely fall in the global gas price and price parity. Energy security, water security, food security, in my view, are closely linked issues.
Yes.
Would you care to comment on the energy strategy of Australia, the different tiers of government, and really the policy framework around which energy resources we develop and which ones we don't?
Yeah, so that's a very broad question. I'd like to say a few words about it. Look, I think it's a good thing to it's a good thing to be pursuing renewables. And I agree with the MIT study that we need to pursue those renewables. But in my view, the time scale that is going to take We may be very optimistic about that. We're talking about disruptive technologies. Now, I've worked in disruptive technologies all my life, and people have been telling me for ages in the semiconductor business that gallium arsenide is going to replace silicon. It has never happened, and it never will happen, because what tends to happen is iteration, particularly when you have trillions of dollars worth of infrastructure invested, namely our power stations. Okay, so I think that, as I see it through just my personal view, I think coal and gas-fired power stations are going to be with us for a considerable time, and they will have to bear that load of powering Australia. The question is, we've got to make them greener or khaki. So we must start taking carbon capture and storage seriously. And what I mean by that is at full scale, not $5 million here and $5 million there. And I think what we need to do in Australia is, it's good to spread our research and development dollars around. You know, typically we divide it between the states, we divide it between all technologies so we don't pick winners, and by the time you've divided it up, you're down to very low numbers. And that, therefore, you're at a very small prototyping scale at best. But there needs to be in there somewhere the resolve to take a risk and go for a full-scale version of what you think is critical.
So, sorry, I might have misunderstood you. You seem to be arguing that shale gas was a better prospect than coal seam gas.
Well, I think
it might be strategic.
Well, I think, look, they're two different technologies, and without getting into it in too details, you know, coal seam gas is quite shallow, it's near the aquifers. Shale gas is very deep, it's a long way away from the aquifers. There are different environmental issues. One might have a better environmental trajectory than the other. A lot of the issues for coal seam gas might go away, for example. But that's not to say coal seam gas is not important. And it's not to say that our exports of LNG is not important. They are important. But surely we can do more than one thing at once. Surely we can export and manufacture.
On that note, I might jump in, and I'm getting wind-up signals from the back of the room. So both Bob and Swee will be around a little bit more today, so you can come and talk to them. But I'd just like to thank them very much, both for very interesting presentations, and thank you very much for your questions. So thanks very much.
Thank you.
Thank you.